So in this video, we're going to be solving linear inequalities that are a little more difficult than the nice problems in the previous video. So our first one that we are going to tackle solving, we have 4x plus 3 is less than 27. So as the previous video mentioned, we are going to go ahead and follow the same steps as solving linear equations. We simplify, make sure we have one variable on one side of the equation. We have an inequality instead of an equal sign. So the only thing we have to be wary of is if we multiply or divide by a negative. So pretty much there's nothing to simplify here. We're going to jump straight on to step 3 with the addition property. We have a plus 3 here, so we got to undo that. What we do to one side of the inequality, we do to the other side, keeping it balanced, so to speak, keeping our statement equivalent. And now we are left with 4x, the 3's cancel out. Inequality does not change, we didn't multiply or divide, is less than 24. And now we go ahead on to multiplication, or in this case division, and we are going to divide by 4. Now we're dividing by a positive number, so we do not have to worry about this inequality sign flipping. It stays in the same direction. 4 divided by 4 is 1. We're left with x. And 24 divided by 4 is 6. Now this is a statement. It is not a solution. So you need to either graph, interval notation, or use set notation to write your final solution. So let's go ahead and see the graph. The graph on the number line, we find 6, that's our point of interest. Strict inequalities use an open circle, and x is everything smaller. So we go to the left towards negative infinity. That helps us with interval notation, which I abbreviate as IN, interval notation. We read from left to right. We have negative infinity all the way to 6. And it's a parenthesis because of the strict inequality not including that 6 value. Last but not least, we have set notation. And set notation just adds some curly brackets, whatever variable you're solving for. Well, in this case, x, right? And we close it off with some more curly brackets. And that's our 3 types of solutions for this inequality. Let's make it a little harder, okay? So next up, we got a little more x's. Let's throw them onto both sides of the inequality. We have 5x minus 3 is greater than 4x minus 2. Okay? Now, we are going to simplify. In this case, there's actually nothing to simplify on the left-hand side, nothing on the right-hand side. So our next step is to notice that we have a variable on each side of the inequality. This is where moving the smaller one to the bigger one helps you so you can avoid the negatives, if that's something you want to avoid, okay? And you might be going, why are you avoiding the negatives? Well, if we multiply or divide by a negative, you have to flip your inequality. So that's what we're going to try to avoid. It's also a little bit nicer to always move so that you have your x on the left-hand side of the inequality. It reads better, okay? So we're going to take that 4x and move it to the other side. How we do that? It's technically a positive 4x, so we're going to subtract 4x. What we do to one side of the inequality, we must do the same to the other side. 5x minus 4x is 1x. You still have this minus 3. The inequality does not need to change. And we still have a minus 2. Watch your sign, don't lose it, okay? Now, after that, we got to get that x by itself, so we're going to do addition property. We're going to add 3 to the other side. What we do to one side, we do to the other. And now we're left with x by itself is greater than 1. And there is our solution. You can go ahead and graph it. I'm going to write it in set notation because it's a little bit easier, and I'm just going to say that is our answer. All right? You can't just leave x is greater than 1, though. That is not a solution. It has to be either graphed, interval notation, or set notation. Again, that one maybe felt a little too nice, so let's escalate this. All right, let's make this problem a little more challenging. And let's throw in some big numbers. Let's say we got 18x plus 18 is greater than or equal to 3 Whoa, that 3 went floating down there. 3 times the quantity, 5x plus 10, n quantity. So we got some parentheses hanging out here. Still the same steps of solving linear equations. We simplify as much as possible. On the left-hand side, there's nothing to really simplify, so let's leave it alone. Right-hand side, we have parentheses, so we're going to use distributive law here to get rid of them. So we have 3 times 5 is 15x. 3 times 10 is 30. And now we have x on two sides of this inequality. So we're going to get it to one side. Usually moving right to left is a nice kind of pattern, or a smaller one to the bigger one. Since it's a positive 15, we are going to subtract 15x. What we do to one side, we do to the other. 18x minus 15x is a nice 3x. We still have that 18 hanging out here. This inequality does not need to change. We haven't messed with anything with multiplying or dividing. And it's still being compared to 30. Now we got that plus 18 there. Don't really like that, so we're going to subtract it. What we do to one side, we got to do to the other. 3x is still there. We haven't multiplied or divided, so inequality stays the same. 30 minus 18 is a nice 12. Now we are going to divide. So this is where you start getting like, okay, is this the exception rule? We are dividing by 3. 3 is positive. You don't have to flip the inequality, right? It's only when you multiply or divide by negative. So we have x is greater than or equal to 4. And you know what? Let's just review what that means. If we were to graph it, 4 is our point of interest. Because it's greater than or equal to, we use a solid dot. X is everything larger, so we go off towards positive infinity. So there's our graph. If you were to write this in interval notation, you'd say 4 including. So you use a square bracket. Infinity symbols always use parentheses. And last but not least, set notation. We have curly bracket, x, such that, and end the curly bracket. And that's the way we'd write our solutions.